Myself, Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today's topic is Civil Engineering Materials. In today's lecture, we will discuss first stone and the second material is aggregate. So without wasting much time, let's begin with the stone. In stone, we will discuss first what is stone, second classification of stone, third various uses of stone, and lastly we will discuss the properties of good stone. Okay, let's start with what is stone. It is a natural engineering materials. Okay, it has been used as a building material from very early times in the construction of the building. The stones, also seen as rocks, by definition are solid natural combination of minerals which forms the earth's crust. They are formed through different natural processes depending on their type. Okay, it is available in variety of colors, form and structures. This is the oldest materials used for civil engineering. Okay, they are strong, durable and decent in appearance. Okay, now let's see the classification of stone. It is generally classified into three types: geological classification, physical classification and chemical classification. In geological classification, first type is igneous rocks. It is formed by cooling and thus solidifying from a molten state. The example of igneous rocks are granite and desert. Okay? This figure is of granite type of rocks. Is of one type of igneous rocks. Okay? Second type of rock is sedimentary rocks. It is formed by a process of cementation of small particles that result from the disintegration of rocks. The example of these sedimentary rocks are limestone and sandstone. This is the figure of limestone. Okay? Third type of rock based on geological classification is metamorphic rock. It is formed by gradual changes in the structures of either igneous or sedimentary rocks caused by heat, water and pressure. The example of these metamorphic rocks are marble, slate and gneiss. Okay, this figure is of gneiss. Now let's discuss physical classification. Okay, in physical classification, first type of rock is stratified rocks. They are derived from sedimentary rocks. Okay, these stones are found in layers, deposit one above the other. You can clearly see number of layers one above the other. Okay, the example of these stratified rocks are limestone and sandstone. Okay, second type of rocks based on physical classification is unstratified rocks. They do not show any type of layer formation like this. Okay, the example of unstratified rocks are granite or marble. Okay, and the third type is foliated rocks. They have tendency to split away in a definite direction only. Okay, so you can cut in definite direction only. Okay? This type of structure is commonly found in metamorphic rocks. Okay, this is the example of foliated rocks. Okay? Now let's discuss the chemical composition, in which first type is siliceous rocks. In this type of rock, silica is principal constituent. Okay, they are hard, durable and not affected by weathering agencies. Okay, the example of siliceous rocks are granites and quartzites. This figure is of quartzites. Second type is argillaceous rocks. In this type of rock, clay is the principal constituent. They are moderately hard, durable but brittle in nature. Okay, the example of these argillaceous rocks are slates and laterites. This figure is of laterites. Okay. Third is calcareous rocks. Okay, the name itself says the main component in this rock is calcium carbonate. Okay, the example of these calcareous rocks are limestone, marble, dolomite, etc. Okay, this figure is of dolomite. Okay, these are the classification of stone. Now let's see the uses of stone, where this stone can be used. Okay, stone masonry is used for the construction of foundation, walls, column and arches. Okay, the stones are used for flooring also. Okay. Stones with good appearance are used for face work of the buildings. Okay. At the elevation of the building. Polished marbles and granite are commonly used for face works. Okay. These stones are used for paving roads, footpaths, and open spaces around the buildings also. Okay. The stones can be used in construction of piers and abutments of bridges, dams, retaining walls, etc. These crushed stones or gravel are used to provide base course of roads. Okay, crushed stones are used in following words also. Okay, as a basic inert material in concrete mix. Okay, as aggregate for making artificial stones and building blocks, and as a railway blast. Okay? These are the various uses of stone. Now let's discuss the properties of good stone. First is durability. Stones selected should be capable of resisting adverse effects of natural forces like wind, rain, heat, etc. Okay. Second is dressing. Stones should be easily carved, molded, cut, and traced to any desirable shape. Okay. Third is color. Stones should have uniform and attractive color. Stones with much iron should be discouraged as the formation of iron oxide disfigures them and brings about disintegration. Marble and granite get very good appearance when polished. Okay? It should have uniform and attractive colors. Fourth is resistant to heat and fire. Okay, resistant to heat means that the stone must have a very low amount of expansion due to large increment in temperature. Okay, sandstone resists fire better compared to other stones. Okay. Fifth is specific gravity. Okay, it can be calculated by taking the ratio of density of material to the density of water. Heavier variety of stones should be used for the construction of dams, retaining walls, docks, harbors, etc. The specific gravity of good building stone is between 2.4 to 2.8. Okay, so you have to select the stone according to their specific gravity. Okay, next is strength of the stone. Strength is an important property to be looked into before selecting stones as a building block. Okay, Indian Standard Code recommends a minimum crushing strength of this stone is of 3.5 Newton per mm square for any building component. Okay. Seventh is structure. The structure of the stone may be stratified, is also called as layered, okay, or unstratified. Okay, stratified stones should be easily dressed, suitable for superstructures. Okay, unstratified stones are hard and difficult to dress. They generally used for the foundation works. Okay. Eighth is texture. Good stone have compact, fine crystalline structure, free from cavities, cracks, patches of smoked or loose material. Okay. Ninth is water absorption. Good stone should not absorb more than 5% of its weight of water when this stone is immersed for 16 hours. Okay. So water absorption should not be more than 5%. Okay. And the 10th is hardness. Good stone should have better resistance to abrasion when these stones are subjected to very heavy loading. Okay. That's all about the properties of good stone. Okay. That's all about this stone. Now let's discuss the second topic or second material in today's lecture, which is aggregate. In aggregate, first we will see what is aggregate. Second, we will see the classification of aggregates. Third, we will see various uses of aggregate. And lastly, we will see various properties of aggregates. First is what is aggregate. Okay. It is an inert material. What is inert? It cannot react with any other materials. Okay. It is an inert material mixed in fixed proportion with cementing material to produce the concrete. Okay. It is used as filler material and used for increasing volume of concrete. Okay. It is responsible for strength, hardness, and durability of concrete. Okay. Now let's see the classification of aggregates. Generally, classification of aggregates is done by these three things: based on grain size, based on origin, and based on density. First, we will see the classification of aggregates based on grain size, in which first type is fine aggregate. So, what is fine aggregate? The aggregate which pass through BIS, which is Bureau of Indian Standard, test sieve number 480. Okay, this one sieve number. Okay, if the aggregates are passed through this 480 number sieve, then it is called as fine aggregate. Okay, its size is less than 4.75 mm. Okay, the example of this fine aggregate is river sand. Okay, this is a figure of river sand. Second type of aggregate based on grain size is coarse aggregate. Okay, it is retained on this BIS test sieve number 480. Okay, fine aggregate is passed through this sieve. This coarse aggregate is retained on this sieve. Okay, the size is more than 4.75 mm. Okay, the example of this coarse aggregate is gravel or broken stones. Okay, these are the example of coarse aggregates. Now, let's see the classification of aggregates based on origin, in which first type is natural aggregates. It is available naturally. Okay, the example of natural aggregates are river sand, gravels, etc. Second is artificial aggregates. It made artificially by man, okay, or in factories. The example of artificial aggregates are broken bricks, broken stone, crushed blast furnace slag, sinter fly ash. Okay, this figure is of sinter fly ash. Now let's see the classification based on density. Based on density, first type is normal aggregate. Its density is around 2300 to 2500 kilogram per meter cube. Okay, the example of this normal aggregate is river sand, gravels, broken bricks, sandstone, quartzite, etc. Second is high density aggregates having density above 4000 kilogram per meter cube. The example of high density aggregates are barite, magnetite, limonite, hematite, etc. Okay, and the third type is low density aggregates having density around 350 to 750 kilogram per meter cube only. Okay, the example of low density or lightweight aggregates are pumice, scoria, sinter fly ash, rice ash, okay, sawdust, etc. These are the lightweight aggregates compared to the normal aggregate. Okay, this is the classification of aggregate. Now let's discuss the uses of aggregate, where these aggregates are used. Okay, it is used to make concrete. Okay, for that aggregates are mixed with cement and water. Okay, second, it is used as filler material to decrease the porosity and increase the strength. Okay, it is act as main load bearing component of concrete. It is used for making lightweight concrete, which is used for soundproofing or insulation or heat proofing. Okay, it is used to make heavyweight concrete, which is used against extra radiation in number of laboratories. It is also used in a number of nuclear power plants. Okay, it is used as road metal, ballast for railway sleepers. Okay, these are the uses of aggregates. Now let's discuss various properties of aggregates. It should be chemically inert. It should not react with any other materials. It should be sufficiently strong to withstand stresses or withstand various loads acting on it. Okay, it should be tough to withstand impacts and vibratory loads. Okay, it should be hard to resist actions of abrasion or attrition. Okay, it should be strong to bear compressive as well as tensile loads which are acting on it. Okay, it should be free from impurities and inorganic in nature. It should be capable of producing workable concrete. Its shape should be rounded, cubical, angular, flaky, or elongated. Okay, these are the various properties of aggregates. That's all about aggregate. I hope you all understand these two materials, stone and aggregate. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe to my YouTube channel, Civil Line. Thank you.